This is Prash Fenn with Math Solving, and today we're doing Volumes by Cylindrical Shells, question 27. A cylindrical hole is drilled all the way through the center of a sphere. Show that the volume of the remaining solid depends only on the length L of the hole, not on the size of the sphere. So I got a sketch here because I couldn't find a picture of the graph, but here's the basic gist of it. There's a sphere, and then someone drilled a hole through the center, which is this part. And the height of the hole is L. It's just a cylinder. You're supposed to be finding the volume of a cylinder, pretty much. And we're gonna have big R be the radius of the sphere, and little r be the radius of the cylinder, or the hole. The cylindrical hole, that's what it is. Sorry guys. Now, we're going to use Pythagorean's theorem to find values that are not exactly x and y, but are very close. See, this is a tricky problem because there's no real absolute values. It's a bunch of variables, which makes it made it difficult for me. It may make it, I mean, you guys may not have a problem, but I do. So you use Pythagorean's theorem, a squared plus b squared equals c squared, and then you say r squared plus L over 2 squared equals big R squared. And L over 2 is B, and R is A, and big R is C. So we can say that X is less than big R and greater than little r. And Y, I'm pretty sure Y is around the value of L over 2, and X is around the value of R, closer than to big R, because if you want to solve for Y with L over 2, you substitute Y for L over 2, you subtract little r squared, so it'd be r squared minus little r squared, and then you'd square root it and you'd get this value. But instead of little r squared, you have x, so I think you have to substitute in x for little r. So y is in between the negative and positive value of this equation. So now that you have a basic x and r, you can do volume. So for this one, we're doing the slicing method. Don't take my word on it. I'm pretty sure it's slicing method. So volume equals integral from little r to big R of 2 pi x times 2 times the square root of r squared minus x squared with respect to x. Or sorry, with x squared with respect to x. Sorry guys. Now equals negative 4/3 pi of r squared minus x squared to the 3/2. And it's in the bounds from r to big R. So when you substitute in r and little r for the x values, you will have to, after you do all that, which will get like 0 and r squared minus x, or r squared, then you have to substitute back in L over 2 for the big R, and you'd get and you'd get 4/3 pi L over 2 cubed. And this shows that the volume depends of the remaining, like after you drill a hole, the volume of the remaining solid depends on the L value, because if you change the L value, it changes the whole value of this expression. Thanks guys, that was Prash Fenn. Sorry for the sloppy video, but there you go. Thanks.